a co-production of the Observatory of York University, Toronto, and the Voice of Astronomy. AFM Radio.
Hello and welcome to York Universe, the astronomy and astrophysics program written and presented by the students, staff, faculty, alumni, and friends of York University. I'm Sana, I'll be one of your hosts this evening, and I'm joined by Shatish.
Hey.
And Kalvisha.
Hello.
We are broadcasting live from the Alan I. Carswell Observatory located at York University in Toronto, Ontario, Canada. Our broadcast is powered by and in partnership with Astronomy.fm, the voice of astronomy. This is Astronomy Night in Canada, where the lineup is all Canadian, starting with ourselves, York Universe, then on to Western World, Quirks and Quarks, and Science for the People. York Universe broadcasts every Monday night at 9 p.m. local Toronto time or Tuesday morning at 2 a.m. Universal time. The York Universe production works in concert with our online public viewing program run by the Observatory team, which runs between the hours of 9 to 10 p.m. local Toronto time. Go to observatory.info.yorku.ca and follow the links or head over to our YouTube page, YorkU Observatory, to join the chat. We will be monitoring the OPV chat room for questions and showing some archival images from our 1-meter telescope. We can't do live imaging tonight, unfortunately, because we've had snow throughout the day. For any questions or comments you have, or any comments on our past shows or suggestions for future topics, please send us an email at observe@yorku.ca. You can always connect with us on Twitter or Instagram with the handle @YorkObservatory and on Facebook at Alan I. Carswell Obs. So, before we get started, how's everybody doing tonight?
Okay, so I am happy. I don't know why I'm happy. It's just that I've got loads of work to do, so that's why I'm happy. Yeah. That's the first, actually. Yeah.
Oh, yeah, I'm happy because I just started building up my new desk setup and stuff. So I'm excited to have everything come in and kind of set that up.
Yeah, that's exciting.
Oh, that's cool. I know.
Yeah, so I'm really excited.
Is it going to come?
Did you guys actually?
Sorry.
No, go ahead.
No, I was just about to ask, did you guys, did you two also see that the cloud of the fuel dump that Professor Delaney was talking about?
No, I didn't.
I didn't either.
Did you?
No, because I have clouds everywhere, so
yeah.
That's not possible.
Yeah. We got snow that night, and I was at the observatory. It was June, so I think I might have been able to see it, but forgot to bring my DSLR camera with me, and I mean, you can't really observe that with the 1 meter, so I didn't get a chance to see it. Okay. I've seen some cool videos of it, though, but it looked really interesting.
Okay,
yeah,
well, good news, yeah.
Yeah.
Yeah. All right, so how about we get started with this week in space and astronomy history, as usual. So I'm going to take us off for space and astronomy history tonight with the anniversary of the Voyager 2 Uranus flyby. So the Voyager 2 spacecraft is a twin spacecraft to the Voyager 1. Both of them were launched in 1997 by NASA to study the outer solar system, particularly the outer planets. NASA had taken advantage of the fact that there was a rare planetary alignment at this point that would allow them to do flybys of multiple of the outer planets at the same time, instead of sending out 4 separate spacecraft to study each 4 of the planets. Voyager 1 targeted Jupiter and Saturn, and then Voyager 2 targeted Jupiter, Saturn, Uranus, and Neptune. So once Voyager 2 was getting closer and closer to Uranus after its Saturn flyby, it started to observe Uranus at longer range on November 4th, 1985, and then did its flyby on January 24th, 1986, with a close approach distance of 81,500 kilometers from Uranus. This is actually, still remains today, the first and the only time that a man-made object has ever visited Uranus, which I gotta say is kind of unfortunate. There's been probes to, I think, most of the other solar system planets. So it's kind of unfortunate that Uranus and I believe Neptune also haven't been observed anymore at close range. But because Uranus has only been visited by one spacecraft, Voyager 2, many of the most important and most in-depth observations of Uranus came from Voyager 2. There has been other observations from ground and space-based telescopes, but I think as we've learned from the many missions to planets and comets and everything, that you learn a lot more about a planet when you send a probe to it to investigate it up close. So many very important observations of Uranus come from the Voyager 2 probe. So here are just a couple of the things that Voyager 2 found while at Uranus. It discovered that Uranus had a rotation period of about 17 hours and 14 minutes, so that's 1 day on Uranus. And it found that it had wind speeds of up to 472 kilometers per second. It also investigated the interior of Uranus and the composition of the planet and found something pretty interesting, a boiling ocean of water about 800 kilometers under the surface of Uranus, and also figured out that the composition of the planet is more or less the same as the other gas giants in our solar system. So primarily made up of hydrogen and helium. And then if you go further under the surface, there's some ammonia, some water, and some methane ices. So pretty much just consistent with the other gas giants in our solar system. There were also, or Voyager 2 also took many observations of several other aspects of the Uranus system, including discovering a magnetic field. So before Voyager 2, it wasn't known that Uranus had a magnetic field, but Voyager 2 detected one, and it turns out that it's kind of a weird magnetic field. It has the same intensity as the Earth's magnetic field, but it's tilted 59 degrees from the rotation axis of Uranus and is also offset from the center of the planet. So that just probably means that the magnetic field is generated somewhere at some intermediate depth within the planet instead of at the core of the planet where magnetic fields are usually generated. So it's probably due to some very intense pressure causing liquid or gases to act as conductors even though they normally don't, and then that generates a magnetic field, which is pretty interesting. Voyager 2 also did some pretty extensive observations of the rings and moons of Uranus. It studied all of the known rings of Uranus. There were 9 at the time. And then it found 2 new rings, bringing the total number of known rings to 11. And in terms of the moons, Voyager 2 took images of the 5 largest moons of Uranus, including coming within only 2,800 or 28,000 kilometers of the moon Miranda. And that was the closest that Voyager 2 had ever come to any body in the solar system during its entire journey so far. So it came closer to the moon Miranda than it did to Uranus. Well, all of these observations of the moons revealed very interesting surfaces on the 5 largest moons, which indicate some complex and interesting geological histories, which were different for each one of them. And it also found 11 new moons at Uranus. So yeah, happy anniversary to the Voyager 2 Uranus flyby. Still got to say, I am kind of disappointed that still there hasn't been any probe sent to Uranus.
You know what, I just have this, like, I wouldn't even call it a thought because that's just connecting the dots. From the very first point that you spoke about, how, the flybys were managed in a way that we used the gravities of more than one planet to sort of send them into their trajectory. And that quote by, I think it was Archimedes, when he said, give me the right place to stand and I'll move the earth. It just flashed, it just came to my mind right now. So what I'm trying to say is, apart from everything else that you just talked about, it is a marvel, and a very old marvel of human efforts and science. And we don't even realize what we've actually achieved. The Uranus and Neptune thing, of course, is something maybe they're planning already. I haven't been looking into it, but we'll get there.
Yeah.
We just crossed the solar system, so it's not far anymore.
Yeah.
I'm sure it has a lot to do with limitations as well, because aside from, I mean, this isn't really just about more missions, but for Venus, for example, although there have been multiple missions, there has only ever been one that's actually given us pictures of the surface. And that's just due to physical limitations with actually landing and getting images or getting close to the surface. So that might have a lot to do with it too.
Yeah. Yeah, I know there are a couple planned missions from NASA and ESA, at least, them. But I don't think there's anything currently like set in stone. Like they're just kind of interesting plans for possible future Uranus missions, but it's nothing like, okay, we're doing this. Like we got funding and we're sending something now, like constructing the mission. So I really hope that there are some missions to Uranus, because I know that with the like even with the other gas giants, Jupiter and Saturn, there were Voyager spacecraft flybys of those. But when you send a probe there and it's like just orbits the thing, you learn so much about the system and the planet itself. So I hope that there is one in the future. Yeah.
Yeah, I hope so too.
Yeah, it would be really interesting. That and Neptune. But we should move on to the next history item. So Palvisha.
Right, so I have the next this week in space history item. So this isn't technically this week, but it was interesting and I wanted to talk about it since it wasn't covered in the last week. So on January 21st in 1960, Miss Sam was launched to space. So during Project Mercury, which eventually launched the first American, Alan Shepard, to space, dozens of astrochimps were trained by NASA. They were trained and then they were generally launched to prove two things. One, that the Mercury spacecraft can be piloted and that its systems functioned accordingly. And two, that mankind could survive the space environment. So one of these many astrochimps was Miss Sam. Miss Sam was a female rhesus monkey, so she's not exactly a chimp, but she's still considered an astrochimp, who was launched aboard Little Joe 1B on January 21st, 1960, from Wallops Island, Virginia. The purpose of her flight was specifically to test the Mercury spacecraft's escape launch system. So her rocket didn't make it into space. It reached a maximum altitude of approximately 9 miles before it descended, but Miss Sam survived the flight and was able to successfully deploy the escape launch system. Her total flight time was around 8.5 minutes. And just in order to train the chimpanzees for their flight, and specifically Miss Sam, she was trained using light cues to pull a lever. And so the fact that she was able to successfully deploy the escape launch systems proved that, one, the systems actually worked, and two, that they were easy to use and could be deployed by the Mercury astronauts as well. So there's not much more about this other than the fact that Miss Sam was launched, but this was a step up with the Mercury mission, and there were several other chimpanzees that were launched to test things out during the Mercury program as well.
I think it's really intriguing, very interesting that she actually did deploy the launch systems, or the escape launch systems.
Yeah.
Yeah.
She managed to stay, as a monkey, she managed to stay calm enough too, but I have read that they did give tranquilizers, or at least some sort of anesthesia to calm the monkeys down before they were launched, but I'm not too sure about that. That is something that I've read, though.
Yeah, I knew they launched animals into space before, but I had no idea that they actually trained some of them to deploy something.
And I'm guessing this is the only example or the only case where someone, like an animal, could actually do something to the flight sequence.
Yeah.
I think there might be more, actually, instances where this must have happened, but I know for sure Miss Sam definitely did deploy the system.
Why did they name her Sam?
Stupid joke. No, actually, I think there is a reason why they're named that. So there was another chimpanzee named Ham, and then Sam. Other than Miss Sam, there was one named Sam, and I think they were named after some NASA facilities, or it was an acronym for something. So one of them was called Sam, and then Miss Sam was just the female rhesus monkey, and then there was another one called Ham, just based off of the same thing. It was an acronym for something.
Okay.
I just don't remember, but yeah, they were actually named on purpose.
You know what? Let's start thinking of names for missions to Uranus in the flyby missions. Let's start right now. Like intense, deep acronyms that nobody will be able to sort of, reject or overlook. Wow.
Yeah, I'm not really good at making acronyms, but I think we could probably come up with some fun ones.
We'll throw a challenge. Anyways, I'm getting too far into this.
Yeah, I mean, I could see NASA throwing it out to the public again and saying, "Hey, name our new probe."
Yeah.
They probably will.
Yeah.
They probably will.
Yeah, I mean, it's what they did with all of the Mars rovers, I think.
So hopefully they'll do that for other probes and stuff too.
Yeah, because it's fun. I think they specifically. This is kind of getting a little maybe off topic, but I think they typically do naming contests for like middle school students.
Mm-hmm.
So that's always like a fun way to get kids involved in science because you have a chance to name some spacecraft, which is pretty cool.
Yeah.
Oh, so curiosity was in. Yeah. Go ahead, please. Keep talking.
Oh, sorry. Oh, I was just saying, like, if the kids win too, it's like you have something that you named up in space, which is really nice on another planet.
Yeah, I know for the Perseverance and Ingenuity launch, there were two kids that named them. The one kid named the rover, and another one named the helicopter. And I think NASA actually flew them out for the launch of the two, so they got to actually watch the launch like live in person, which is also really, really cool.
Yeah, that's really lucky that they got to do that too. Wow.
Mm-hmm. Yeah. All right, so Shatish, you're up next with another interesting launch.
Yeah, actually a humble one, but the name is interesting. So January 25th, and this is not too far back in time, like at least within my lifetime. 25th of January 1994, Clementine was launched. And it was a spacecraft. For all practical purposes, this was meant to be a selenocentric mission. It was meant to make scientific observations of the moon and also a near-Earth asteroid, 1620 Geographos, which is a potentially hazardous asteroid, which happened to be nearby after 2 centuries, and that was part of the plan. Like, that was the reason it was launched, as in the mission was launched. Now, selenocentric, of course, some of us know, most of us know, all of us know, is just a fancier name for a lunar-centric orbit. And what other purposes did Clementine intend? Well, I didn't say it did, just a figure of speech. But Clementine was an official deep space program science experiment, which, besides being a space project, was also a collaboration with the Ballistic Missile Defense Organization, previously known as Strategic Defense Initiative Program, which might ring a few bells. I wouldn't get further into that because that's not the topic here. So the official objective was to test sensors and spacecraft components in long-term exposures to space. It was launched on the date to coincide with the closest approach of Geographos asteroid, and there was approximately 7 million kilometers from Earth. That's when the spacecraft was probably supposed to interact with, or probably reach the asteroid. I'm not sure. But a malfunction in this spacecraft ended this objective of the mission before it could reach the asteroid. And just technical details remaining here. So Clementine was launched using a Titan II launch vehicle and carried aboard a charged particle telescope, an ultraviolet camera, a near-infrared camera, a LiDAR, a high-resolution camera, typically an experimentalist's dream lab, if you will, and They also improvised a bistatic radar experiment while it was up there in space, and it still was operational, to look for signs of lunar water at the moon's poles. And radio signals were reflected from both the poles and detected via the deep space network to initially suggest some kind of volatile ices. Although these interpretations were later ruled out during further analysis using the Arecibo telescope, and basically they didn't confirm that the polar regions really had actual water. So it was an interesting mission, no doubt. It probably had loads behind the scenes needing to be done, which it couldn't do. Happy birthday, Clementine.
It's an interesting mission. I hadn't heard of Clementine before.
I'm
Yeah,
hoping I didn't pick up anything wrong. Like it shows on Wikipedia still.
so Geographos is potentially hazardous to Earth. That's
Like an
are
Earth
we
aspect.
supposed to be? Should we be concerned about it?
Oh no, that's at least 5,000 years from now that it'll come back that close to Earth. So technically, it is probably one of the potential asteroids, or like potentially hazardous asteroids. But I think its next approach close to Earth will be somewhere in 2500 something. I can actually confirm this for you if we keep
Oh,
looking. Yeah, like, but I'm saying like, so that's not a bother anymore. Maybe something else is more hazardous now for us than probably this asteroid. I'm still trying to find out. Yeah.
We could actually have asteroid like systems to protect the Earth from asteroids. Because I know that there's that double asteroid redirection test thing. It launched a while ago, I
DART.
think. Yeah.
DART. Yeah, I was this whole time, as you were talking about this, I was just thinking about the DART mission.
Maybe the DART mission is a consequence of something like this, and maybe they did want to try and deflect this asteroid back then, and they missed. I'm sorry, I'm still not able to find the exact place where I read when it's supposed to come back, but it's not coming back anytime soon.
Yeah. So it'll be future humans' thing to deal with.
If they keep the Earth the way it is, yes.
Yeah. Yeah. Another interesting thing about this is I've never actually heard the word selenocentric before. And I'm kind of amazed that I never heard that word before. And
Honestly.
it just like lunar centric, right? But I never heard that selenocentric word before.
Yeah, it was new
Neither
vocabulary
way.
for me too.
Yeah. I was just trying to be like acting normal so that, maybe I was the only one who read it the first time and others knew it. But now that the cat is out of the bag, okay, I really can feel relieved.
Yeah, it's interesting. Yeah, I thought it was just going to be something like lunar centric or something. I didn't know they'd come up with a different word for it.
Yeah, and I think there's only like two events. I'm surprised. A couple of weeks ago, I think we did cover something which one of our satellites is actually lunar centric, and the word didn't come up even then. So
Yeah.
That's weird.
Yeah, it might just be one of those words that like when people write articles about it, they don't bother saying selenocentric because most people won't recognize it, so they may just say like lunar centric, but then it comes up in like other things.
See, that's how language dies. People should understand that. Only linguists will actually talk about things like that. So, excuse me.
Yeah. All right. Well, we should probably move on to the next history item, which is the anniversary of the Opportunity rover landing on Mars. So just like the Voyager 1 and 2 spacecraft were launched together, Opportunity was launched with another Mars rover called Spirit, launched by NASA in 2003. The pair were built as part of NASA's Mars exploration program, which was basically just intended to figure out if there had ever been life on Mars, or if the conditions for life had ever existed on Mars, and to generally just study the climate and geology of the red planet. So on January 25th, 2004, the Opportunity rover landed in the Meridiani Planum. I'm probably not saying that right, but it's just a plain near the Martian equator, which is where it gets the name Meridian Planum. And this is only a couple of weeks after the Spirit rover landed on the opposite side of the planet. Both of the Spirit and Opportunity missions were groundbreaking, with Opportunity turning into the longest running Mars rover ever. And it's really got to be one of the most important missions to Mars, or one of the most successful missions to Mars, if not the most successful one that's ever been done. Both of the rovers were initially designed to only last for 90 days, but both of them ended up lasting for many, many years. They did an incredible amount of science, including finding a ton of evidence for past liquid water existing on Mars. So Opportunity and Spirit were the first rovers to do this. And they proved that it had existed for substantial periods of time on Mars, possibly forming lakes and flowing in valleys and everything. So very, very interesting and groundbreaking discoveries made by the rovers. Opportunity specifically found evidence of rocks like hematite and other things like sulfates and crystals and some other kinds of rocks, which all needed water to form, or typically form in water. So their existence provided evidence for decent amounts of liquid water in the past on Mars. All of this was found within the initial 90 days of the mission and was found at its landing site. But soon the rover went out of, or roved away from its initial landing location and visited two craters, Victoria Crater and Endeavour Crater. So the first crater that it went to was Victoria Crater, and scientists wanted to send the rover inside the crater because there was some very interesting stuff. They could, as you go deeper and deeper down into a crater, there's some exposed rock on the sides. So if you go further and further down, you can reach older and older rocks. So the scientists really wanted to be able to get into this crater so they could investigate the rocks. But it was a pretty risky thing to do because it was kind of unknown if they would be able to get Opportunity to climb back out of the crater, or if it would just get stuck in there. But since the scientists really thought that it was worth it to investigate the inside of the crater, they decided to just go for it. And it paid off. Opportunity found a bunch of ancient rocks and exposed material that allowed it to study the past wet environments on Mars. And it was able to climb out of Victoria Crater and eventually go over to Endeavour Crater. It made a bunch of, or many more interesting discoveries in Endeavour Crater. It was just as successful as Victoria Crater was, at least, and including finding some very interesting rocks, including one called Esperance, which is made of clay minerals that have to be produced by water. So it yet again found more evidence of water on Mars in Endeavour Crater. It also found some rocks with large amounts of aluminum and silicon in them, which had never been discovered on Mars before. Unfortunately, the mission ended in 2018 because of a massive dust storm on Mars. Mars can get these huge and powerful dust storms that just kind of engulf the entire planet. And this is a problem for the Mars rovers because they are solar-powered rovers. So when these dust storms come by, they cover the rovers in dust. And if you have no way of getting the dust off the rover, it just blocks sunlight from hitting the rover and charging the batteries and giving it solar power that it needs to function. Sometimes there is wind on Mars, or these little dust devils that can kind of dust the, or remove the dust off of the solar panels. And it had happened actually before. There are some rovers and other things on Mars that had their solar panels covered in dust, but then wind just kind of blew it away. But unfortunately, this didn't happen with Opportunity. It sent its last messages to Earth on June 10th, 2018. Scientists then tried to get into contact with it a few times after that and listened for signals coming from the rover, but they never heard anything. They sent the final commands to wake up the rover on January 25th, 2019, but they just never heard back from it. So NASA officially ended the mission on February 13th, 2019, with Opportunity still in Endurance Crater in a valley that they named Perseverance Valley after the rover's perseverance through its lifetime. So all in all, Opportunity lasted for 14 years, or 5,110 sols, and traveled a little over 45 kilometers on the surface, so far exceeding its original 90-day mission plan and making it the longest lasting rover on Mars. So happy anniversary to Opportunity landing on Mars.
Yeah, I remember when the Opportunity mission came to an end. That was very, very disappointing. I wonder if they'll ever maybe try to equip their little like robotic helicopters with like dusters to kind of, help the rovers out.
Yeah, I think like that's one of the benefits for Ingenuity is that like when it flies, it can kind of dust off the solar panels a little bit. I'm not too sure about that though, but at least it's different than the rovers that have to kind of rely on a little dust devil coming by and removing the dust.
Yeah, and I remember that specific dust storm wasn't expected to be like to happen at that time either.
Yeah, wasn't that during the opposition a few years
It
ago,
was.
and we did this like whole thing at the observatory, and we were supposed to get these great views of Mars, but you couldn't see anything because of the dust storm. So
that's exactly what it was. It was during opposition, and then we had that, plus the weather was pretty bad too. So we couldn't see anything.
That. Yeah, that sucked. Yeah, well, it was worse for Opportunity because the dust storm kind of killed it. But yeah, that's sad. But Opportunity was a great mission. I mean, you really couldn't really ask for anything better. A mission supposed to last 90 days, lasting 14 years is just, you really can't complain about that. Yeah. All right. Well, Palvisha, you're up next. We should probably move on to you.
Yep, so I have the next This Week in Space History item. This one is a little grim and a good reminder of how far NASA's come in just in their practices with ensuring safety and preparing for emergencies. So on January 27th, 1967, we lost a crew of 3 in the Apollo 1 capsule fire. So the Apollo program was the program that would eventually make Neil Armstrong and Buzz Aldrin the first men to land on the moon. And this specific feat was accomplished in the Apollo 11 mission launched in 1969. However, there were many missions prior to this that were also a part of the Apollo program. And the first of these was a crewed mission called Apollo 1. So this Apollo 1 mission was initially designated as AS-204, but then was later renamed. And it was supposed to be launched on February 21st, 1967, with a proposed mission length of 14 days. This mission was supposed to be the first low Earth orbit test of the Apollo Command and Service Module. So the Apollo Command and Service Module was one of 2 components of the Apollo spacecraft, and it acted as the mothership or the home base during the Apollo 11 mission, where it carried the crew and was attached to the lunar module, and where it brought both to the moon and allowed the astronauts to come back. Unfortunately, while Apollo 11 was successful, Apollo 1 never had the opportunity to launch at all. Because on January 27th, about a month before its expected launch date, at Cape Kennedy Air Force Station, Launch Complex 34, a cabin fire started during a launch rehearsal test with the service module, and with it, the first crew of the Apollo mission, so Command Pilot Gus Grissom, Senior Pilot Ed White, and Pilot Roger B. Chaffee were lost in the tragedy. So AS-204, which was what it was formerly known as, was renamed to Apollo 1 officially due to in order to honor the crew that had chosen its name. The investigation that followed the incident revealed that the cause of the cabin fire was electrical, And the reason that the fire grew and intensified so rapidly was because of the high pressures inside the cabin and due to the large amount of pure oxygen within the cabin environment. Also, the nylon material was within it was also combustible, so all of that combined to form a really bad environment for the fire to grow in. And so the reason that the crew themselves could not be rescued was because of the intense pressures from the fire within the cabin. The plug door hatch couldn't open against that pressure, and the crew couldn't escape. Another factor that played a role in the fact that they could not be saved was the fact that NASA didn't really prepare for emergencies with this test. It was supposed to be unfueled, and because it was unfueled, they deemed it to be unhazardous and weren't well prepared. So that was another factor that played a part in the tragedy. Following this incident, crewed flights for the Apollo program were halted for almost 20 months while the CSM's issues were resolved, and it seems that NASA has come quite some ways from incidents like this, and so it also is just, I guess it just serves as a reminder about all of the effort that's went into getting us to the moon and to where we are right now in space exploration.
You know what? That's one thing that I've never had a comment upon, because it was a tragedy. We sort of taught us probably a lot, and that's all we can say about it.
Yeah.
By the way, just like to change the mood, and of course, I'll probably move on when you ask me to. But I did check the geographers thing again. So the reason I was probably hovering around something which is not pretty clear. They do mention that it would not be until 2586 that its closest approach will be as good as it was in 1994. Although I'm not sure how correct those numbers are, but it still is on Wikipedia. And then the reason it sort of is a hazardous asteroid is because it probably is within the range of the minimum orbital intersection distance. So I found the year basically. However, if you go on other sources, you would actually be able to find its closest approach in the next few decades also. And nothing really comes close to 7 million, if that was the right number, except for something in 2051. So yeah, change of topic, and yeah.
Yeah.
Yeah,
All right, so we are running a little short on time here. So Satish, you should probably go on with your birthday shout outs.
Happy to, and quickly. So January 24th, Harold Babcock in 1882. He was an American astronomer who specialized in solar spectroscopy and worked at the Mount Wilson Observatory. He precisely mapped the distribution of solar magnetic fields, working alongside his son, Horace Babcock. And there's a crater on the moon and an asteroid named after him. January 25th, 1736, Joseph Louis Lagrange. We know a lot about this person. He was an Italian mathematician and an astronomer, known immensely for his contributions to number theory, analysis, and classical and celestial mechanics, calculus of variations. And he did work on the three-body problem that gave us what we today know better as the Lagrangian points, the three bodies being Earth, Moon, and the Sun. And also, January 27th, 1941, Beatrice Tinsley, a British-born New Zealand astronomer and cosmologist who taught at Yale and made fundamental contributions to our understanding of galactic evolution, specifically the first approximations of how protogalaxies should look like. So happy birthday to all three of these. Related.
Yeah, Lagrange is very important, especially today with the recent news that's come out. Um, and that's actually something I'll be talking about in a bit. But
Yeah, yeah, some interesting things about these Lagrange points coming later. But so this kind of marks our midway point between the this week in history and space news. Sorry, I blanked on that word for a second.
That's all right.
Yeah. For those of you who are just tuning in, you're listening to York Universe, broadcasting live from the Alan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. You're listening to Shatish, Palvisha, and myself, Sana, currently discussing some astronomy history. Go to observatory.info.yorku.ca to join the online public viewing chat room to ask us any questions you may have and to see some images taken by our observatory team. You can also connect with us on Twitter or Instagram with the handle at York Observatory and on Facebook at Alan I. Carswell Obs. We have a couple interesting news stories coming up tonight, but before we get to that, we do have one reminder, which is about our weekly Teletube on Wednesday. We broadcast live every Wednesday night at 7:30 p.m. over on our YouTube channel, URQ Observatory. And this week, we're going to have a guest, Rosela, who has been the observatory's co-op student for, I believe, the fall semester. She's going to be giving us a presentation about her time working at the observatory and sort of things that she's done. So that should be a very, very interesting talk from Rosela. So make sure to tune in. And we will also be doing live imaging using our 1 meter telescope if it's clear, as usual. But moving forward, we do have a couple very interesting news stories tonight, and Palvisha is up first with another update on James Webb.
Yep, so for my news item, I'm just going to provide a bit of an update to the James Webb Space Telescope. So just starting with a bit of background for everyone, the James Webb Space Telescope, the successor of the Hubble Space Telescope, was finally launched after years of delay on Christmas morning, December 25th, 2021, from French Guiana. Webb will orbit the Sun at the second Lagrange point, L2, named after Joseph Lagrange. And the journey from Earth to L2 is approximately 1.5 million kilometers and takes around 30 days. And so considering that Webb was launched on December 25th, it is almost, or well, I'm going to provide a bit of an update about that, but it has reached L2 today. So during the 30 days of its trip from Earth to L2, the telescope undergoes hundreds of procedures for proper deployment. And this morning, it completed one other milestone, and that was arriving at L2 itself. It reached the L2 location and fired its rocket thrusters for approximately 5 minutes before successfully going in orbit around the Sun. So while this is another major success for this mission, there's several other deployment procedures that are going to follow this, and those namely include that the mirrors of the telescope need to be aligned, the infrared detectors need to be chilled, and the scientific instrumentation on Webb is supposed to be appropriately calibrated. So there are a few more milestones that it does need to achieve, but this was a really big one that happened this morning. Despite this, there are, because of all of the procedures that still have to be completed and the time they'll take, the first observations won't begin until June of this year. And that's assuming all other procedures are successful. However, once it is deployed and ready for observing, Webb will allow astronomers to look back in time to the formation of the first stars and galaxies approximately 13.7 billion years ago and study the atmospheres of other planets for signs of life. Webb is expected to last for over a decade, assuming there are no mechanical problems that arise during its mission. Unfortunately, unlike Hubble, Webb can't be repaired due to its distance from Earth, and so the remaining procedures and any procedures that follow during its mission are critical to Webb's lifetime. For now, we can celebrate today's success and hope the rest goes smoothly. So congrats to Webb for completing another milestone.
I gotta say that it is kind of surprising to me that this mission has gone so well.
Don't jinx it.
I know. I know, like knock on wood, but it's just this thing is so complex, and especially some components like the sun shield. I gotta say that I'm pretty surprised that it kind of it got through all of these deployments without any major, like, oh my God, are we going to lose the telescope kind of errors or malfunctions or something. So I'm very happy with this, of course, but it's a little surprising to me that it went so well.
I hope it stays this way, and I hope it continues to stay this way for like several years too, because if anything goes wrong, it's like you can't really fix it either.
Yeah, especially thinking about like the start of the Hubble Space Telescope program, of how the mirror was slightly like the curvature of the mirror was slightly wrong, and all of the telescope's images were blurry. I kind of worry.
Yeah, I hope especially that milestone with aligning the mirrors and chilling. I hope those go okay. I think the chilling should be fine, because at its L2 position, it's always out of the, like, it's not getting direct sunlight. So it's always in the dark and it will be really cold, but just the mirror alignment specifically, I hope that goes well.
Yeah, that's gonna take like 3 months. It's gonna take a very
When
long time.
do we know when they expect to probably have the first images, like
The
approximately?
Um,
first,
late
first,
June, early July.
yeah, first observations won't be made until June.
Yeah, they said
Oh,
I was watching some of these like uh, Q&A sessions that NASA has had, and they said that like they're not planning. They're technically going to start imaging soon because you have to image stars to align the mirrors, but they're not planning on releasing any of those images because they're just going to look bad. So they're this is going to be like you're aligning to a star and you have like a super blurry and star that maybe doesn't really look like a star because you're trying to align the mirror segments. So they don't want to be like, okay, here's a $10 million telescope that produced this horrible image. Um, so they're going to come up with a set of like wow pictures that has the telescope functioning like exactly how it should be. And they're going to release those first, and to kind of show everyone like this is what this telescope is capable of. This is why we just spent $10 billion and like 30 years doing this. Um, so yeah, I'm really looking forward to the first pictures and getting the first sets of data in. So June and July cannot come fast enough.
that is true. That was a nice way to say it. The pictures wouldn't look good. I mean, that big a telescope. It's like, when students take the first picture and they try to process it and it's not coming up properly and they're worried about their grades and the timeline and everything. Imagine that thing happening to the team of scientists at NASA. So,
Yeah,
yeah,
yeah.
yeah,
Oh man.
bad joke, like I said.
Yeah, is just thinking about like NASA's released like a couple little videos of more or less like how the mirror alignment works in like 10 seconds, and it looks easy looking at that video, but they have to run so many like programs and everything to analyze the images and figure out how to make these like 18 mirror segments just work as one big mirror. So it's insanely complicated.
Even
Um,
without the science or the technicality, for example, when people talk about being on the shore of an ocean, some people begin to think of existentialism and all that, like whichever are the biggest shores in the world. Uh, if you try to think as a human that you're there with the telescope, that's not something that I'm sure anybody has actually imagined. I mean, yes, we have a space station. Yes, we are doing all sorts of things, but that is not easy. Like, so when it cannot look easy even in those videos is what I'm trying to sort of abstractly say. It's it's amazing what they've tried to do and what they'll
mhm.
probably keep trying to do for so many years.
Yeah,
Hey.
yeah. One thing that I noticed, because when I watch these like these Q&A things and these media briefings, it's like more than one person asked, is it really as hard as you say it is? And it's like this question got asked more than once, and it's just like, oh my gosh. Like
Seriously,
this is like the most complex space telescope that has ever been launched, and you're asking like, oh, is it really as easy as it is, as like really as hard as you say it is? Like, of course it is.
Even if you thought you wanted to just deploy like a football or a baseball at that point, even that mission will be supremely difficult. And I guess that's the sentiment I was trying to relate to. Like, why would people think is it that difficult?
Yeah. So, like it looks easy because they've like trained for everything. They went over the deployments before it launched in like simulations and trained for it. So, I mean, it kind of does make sense that they could do it very well now because it's not the first time they're doing it, but it's still like sometimes I don't think people realize like how insanely hard space can be just to begin with. Like you said, even doing a simpler thing is incredibly challenging. So, yeah.
Let's reinvent the wheel is all I can say then, if it's not difficult. I'll continue to talk rubbish if you don't stop me, so let me know when you want me to move on.
That's a good idea because I think we can probably all talk about how amazing JWST is for a very long time. But you have another very interesting news story, so go ahead.
Sure. So let's take our attention away from the great telescope to the great, move it to a great rover, Curiosity. The latest pictures from the Curiosity's mission have been released, and latest details have been released. So the one thing that I cannot really corroborate properly is that they released a picture of a crater, which I like to think of as like a big boot print. But what the website Mashable says is it's like a dune-filled crater, so you should go check that out. Well, the rest is more science. So they've released the information from the rock samples that they've been studying. So there is a type of carbon in the rock samples that bears association with certain biological processes on Earth. However, and this is the more important piece of the news perhaps, that is not an indication of earlier life on Mars. Like, simply put, the usual stuff of the variety of a sedimentary rock formation produced by bacteria, or signs of complex organic molecules in a variety that may be connected to a flourishing life, it have not yet been inclusively found. This is January's data I'm talking about, like this month itself. But then, conclusing is the operative word here, along with the need to let go of the idea about how life has evolved on Earth. So the carbon signatures detected are unusually intriguing, interesting, and hence they call for an out-of-the-box way of interpreting the chemistry and the environmental processes in a Mars-like environment instead of what we have on Earth. You have to like detach yourself from what we already know. And the surface analysis reveals a much stronger concentration of the carbon-12 that we Earthlings actually metabolize. They didn't find that when they were just studying the atmosphere. So this is the surface. But we find that because of a very well-sustained carbon and life cycle, like as far as Earth is concerned, it's not the same thing on Mars. So now they're trying to explain what's probably happening or what's been happening at Mars is that maybe Mars may have started off as a mix of many carbon isotopes, but since it's cooler, smaller, and with a weaker gravity, the carbon cycle may just have sustained alongside the gases in the atmosphere, but without any life or a cycle that would support any life. So the challenge for now then is to be able to read the carbon cycle as it truly did evolve on Mars, and if the idea of life even fits into it at all. For example, the examination of methane plumes they were found earlier, and now to see if it is consistently available in other locations. So basically, keep watching. Like, I am done because there's loads I can go on with this, but that's the crux of the story.
I always love the stuff coming out of the Mars rovers. Like I'm more into extragalactic, or like kind of extragalactic astronomy, but the Mars rovers just in general are really amazing to me. And the things that these little robots can discover on other planets.
Which is kind of cool. It's not as scary as the Lagrange points we were discussing earlier. Because I think it's probably because we think of robots as minions, maybe. Maybe that's just my vision. So we're like, okay, fine, yeah, cool. So we have a robot, what the heck? But I'm not sure if I should be that excited about this particular discovery because I have not been following the Martian news so much. But if it really is that intense as it says, and of course it's a big change in the perception that we've had till now, life on Mars.
Yeah. I think this also kind of raises an interesting point of when we kind of base our understanding of the cycles on other planets based off of what we see here on Earth, where maybe this might be true for Earth and for some planets, but there's kind of a limit to what it can do. So we always need to be thinking basically outside of the box about how things could be different on other planets.
Yeah, I think that's part of the research is when people try to say that, well, life has existed on Earth in difficult environments like boiling geysers and even like the coldest places on the planet. And then people also try to talk about maybe life exists in an inorganic form. So, and of course, our fiction movie directors have done a great job of trying to think all sorts of possible life forms, including Transformers, by the way. So you never know, actually. And if they're as advanced as Transformers, then there's no way in whatever place you think of that you can actually find out if they're there or not. Yeah. I'm getting sidetracked. Just adding.
Yeah, very, very interesting stuff about Mars. So I'm going to quickly go over the final news item this week. Is new observations from the Hubble Space Telescope about how a black hole is causing star formation in a galaxy. So black holes can do two things. They can, when they accrete matter, or basically eat the stuff around them, they can make jets and do a lot of things to influence their environments. And one of those things is that it can send massive shock waves or jets out of the black hole, which can compress clouds of cold gas and cause star formation. This has been observed in massive galaxies before, but for the very first time, it has now been observed in a dwarf galaxy, Heinze 2-10. This galaxy had been observed previously in radio, X-ray, and some optical imaging from the Hubble Space Telescope. And now there has been some spectroscopy follow-up of the galaxy, again from the Hubble Space Telescope. And astronomers have now confirmed that there is, first of all, a black hole in this dwarf galaxy. And second of all, that it is ejecting two jets, one of which is running directly into a star-forming region and triggering star formation there. So this is a very, very interesting discovery, in part because this is happening in a very small dwarf galaxy. So like I said, it's been observed in bigger galaxies, but never in small galaxies. And the reason that observing this in small galaxies is important is because galaxies today, like the Milky Way or some other massive galaxies, probably began their lives as small dwarf galaxies. So when we can observe the way that the central black holes and galaxies influence their environments, we can learn a lot about early galaxy evolution, which will be relevant for studying early galaxies and how they evolved and how galaxies came to be today. So the authors do note that galaxies like Heinze 2-10 are very hard to find. They're not common and they can be pretty dim, so hard to find. But as with most things in astronomy at this point, everyone is saying that JWST is going to solve this mystery. They're hoping to use the James Webb Space Telescope to find many more dim galaxies like this. And this is just one of the many more things that we can look forward to with James Webb. So unfortunately, we are out of time tonight. And for everyone listening, you've been listening to York Universe. the Astronomy and Astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Satish, Palvisha, and myself, Sana. Stay tuned because it is Astronomy Night in Canada, coming up as Western World, Quirks and Quarks, and Science for the People. You can always connect with us on Twitter at the handle @YorkUniverse, and check out our website for show notes, content, updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a good night.